Hello, you are welcome to New Focus Approach to Mathematics Basic 7. This is the revised edition, and in this video, we are looking at how we can express vectors graphically. So we have different types of expression of vectors, or we have different ways of expressing vectors. We can do components, we can do magnitude bearing form, we can do graphical method, and we can even do Cartesian method. But in this video, we want to focus on graphical approach in representing vectors. Before we do that, let's understand the basic concept about vectors. Now we have two types of physical quantities. We have the vector quantity and scalar quantity. When we talk of physical quantity, we are just making reference to quantities that can be measured, like um, weight, force, velocity, mass, length, and so on and so forth. All these physical quantities can be categorized as vector and a scalar. Those that can be called vector quantity, they have both magnitude and direction. For example, force. Okay, force has both direction and magnitude because we can measure it with some amount and we can also know the direction it goes. We have displacement, we have velocity, we have acceleration, we have momentum, we have weight, and so on and so forth. All these quantities or physical quantities, they have both magnitude and direction. Good. Then we also have scalar quantity, where we say it is a quantity that has magnitude but no direction. For example, if I talk of time, time, I can give you maybe this video ever since I started, I've spent 1 minute 50 seconds. That is the time, that is the magnitude, but there's no direction where it is going. And so it is a scalar quantity. Then we talk of speed, talk of distance, mass, density, temperature, volume, area. I mean, they are all physical quantities, but they can be described as scalar quantities. Good. Now, I want to concentrate on the vector quantity and want to learn how to represent vectors graphically. So here we can see that we have vector A, vector B, vector C, and we want to represent vector A, B, and C. Now, vector A simply means that we have x component and y component. X is 3, y is 4. That means from the origin, we move 3 steps on the x-axis and 4 steps on the y-axis. Where they meet will be here. Then we draw a line from the origin to that point, and we call it vector A. It has direction and there is magnitude. I can measure the distance from here to here. Okay, and I can also know that the direction means it's going this way, right? So that is for A. Then the B also says that -2, 4. That means from the origin we move to -2 and then we move positive to 4. So it will meet here. Then we join our line to that. And that is the vector B. Then vector C says -3, -4. -3, -4. So from the x-axis, I'll move -3, then I'll move -4, and that also meets here. So then I join that. So I get my vector represented graphically. Right. Now let's look at something again here. It says write each of the following vectors in the form A, B. Now we've learned how to represent vector using the graph. This time around, I want to give you the graph and you want to read the vector out of it. So if you talk of vector AB, okay, vector AB, what it means is that I'm at A and I'm moving to B. The direction goes like this, AB, right? So what is the value, or what is the vector? What is the direction that I'm moving? So from the A on the x-axis, I move 0.1, 0.2, 3, 4, 5, 6, 7. Then I move upwards 1, 2, so that I have 7 on x-axis, 2 on y-axis. And the 2 is positive because I move upwards. 7 is positive because I move towards the x-axis at the positive side of the x-axis. If I'd gone back, I could have made it negative. And if I go down, I'll make it negative. And so on the y-axis, if you go down, it's negative. If you go up, it's positive. On the x-axis, if this is your origin, the moment you go this direction, it means you are going negative. And when you go this direction, you are going positive. Right? So that is the answer. Now, let's see the next one. We want to do it for BC, vector BC. So BC. Then BC means I'm at B and I'm heading towards C. The direction is like this, BC. And how do I get to BC? Then it means I can't move forward, because when I move forward, I'll be away from that. It means I have to move backwards. And it's always with x-axis first. So I move backwards 1, 2, 3, 4. Okay, that is -4. So it means I'm going to start with -4. Then I move from there 1, 2, 3, 4, 5, 6, 7. -7 as well. That means -4, -7 will take me to the C from B. Then let's look at the last one, AC, vector AC. AC means I'm at A and I'm heading towards C. So A towards C. Okay, so if I'm going A towards C, what will be the vector? Now, I can't go backwards, because when I go backwards and I go down, I will not get to C. I must go forward and go down. So forward, how many steps will I move on the x-axis? So 1, 2, 3. So that means I'm going to have +3. Then I go down 1, 2, 3, 4, 5. So that will be -5. So the vector AC is 3, -5. I'm sure this has really helped you to understand the concept of representing vectors using graphical means. Right. We'll learn more about vectors. Thanks so much for watching.